When people think of anti-inflammatory plants, they think of turmeric, the golden powder, the lattes, the capsules lining health food store shelves. Turmeric has become the default botanical answer to inflammation. Marketed globally, researched extensively, cultivated across the tropics at industrial scale. The compound curcumin has been the subject of thousands of studies. The association between turmeric and inflammation is so firmly established that it barely requires explanation. But turmeric is not native to North America. It does not grow in the forests that once covered the eastern United States. It was not part of the pharmacopoeia that indigenous peoples of this continent developed over millennia. A different plant filled that role. It grew on the forest floor of the Appalachian Mountains, shaded, slow, hidden beneath hardwood canopies in rich, undisturbed soil. It was small, inconspicuous, producing only 2 leaves and a single cluster of red berries. The root was bright yellow when cut, staining everything it touched. The plant is called Goldenseal. It contains berberine, an alkaloid that laboratory research has shown to possess antimicrobial, anti-inflammatory, and metabolic properties. The compound appears in several plants worldwide, but the concentrations in this particular root, combined with other alkaloids unique to it, made it one of the most valued medicinal plants on the continent. Cherokee healers used it. Iroquois practitioners prescribed it. By the 19th century, it had become one of the best-selling botanical medicines in America. It was so effective, so sought after, that something unusual happened. It was harvested nearly to extinction, not because it failed, because the demand exceeded what a slow-growing forest plant could sustain. The question is not whether this root had biological activity. The traditional record is extensive. The chemistry is documented. The question is why a plant this valuable, native to American soil, used by American healers, sold in American pharmacies, was driven to the edge of disappearance and then forgotten, while a tropical import took its place. The plant belongs to the forest, not to the field, not to the garden, not to any landscape shaped by human intention. It grows in shade, deep shade, the kind found only beneath mature deciduous canopies in forests that have been undisturbed for generations. It favors north-facing slopes where moisture lingers and direct sun rarely penetrates. It needs rich, humus-heavy soil built from decades of leaf fall. It grows slowly. It does not tolerate disturbance. This is not a crop. This is a forest organism woven into an ecosystem that takes centuries to establish. The indigenous peoples of eastern North America understood this. The Cherokee used the root for digestive complaints, for skin conditions, for what their healing traditions described as inflammation and infection. The preparation methods varied, infusions, poultices, washes, but the applications were consistent. The root was used when tissue was irritated, when wounds needed treatment, when illness settled in the throat or gut. The Iroquois Confederacy knew it as well. Multiple nations within the Confederacy incorporated the root into their pharmacopoeia. The uses overlapped with Cherokee practice but were not identical. Some nations used it for eye complaints, washing irritated eyes with dilute preparations. Others applied it to wounds. The specifics varied, but the core recognition was the same. This root had properties that aided healing. The Delaware used it. The Chippewa used it. Across a range spanning the Ohio River Valley to the Great Lakes, from the Appalachian ridgelines to the forests of the interior, different peoples had independently incorporated this root into their medicine. The convergence matters. Multiple nations, with distinct medical traditions, developed similar applications for the same plant. This is the pattern of empirical observation, not shared mythology, but shared outcomes. They used it because they watched what happened when they did. The knowledge entered European American awareness through the channels that most indigenous knowledge traveled, slowly, unevenly, often without attribution. By the late 18th century, frontier settlers had begun using the root. Some learned directly from indigenous practitioners. Others acquired the knowledge secondhand, through the informal networks that moved information along the frontier. The root's yellow color made it recognizable. The staining was distinctive. Once encountered, it was not easily forgotten. The formal adoption came through the Eclectic physicians. The Eclectics were a school of American medicine that flourished in the 19th century. They rejected the harsh treatments that dominated conventional practice, the mercury, the bloodletting, the purging, and instead emphasized botanical medicines derived from the American landscape. They were not folk healers. They were trained physicians who published journals, maintained colleges, and developed systematic approaches to plant-based treatment. The root became one of their most important medicines. John King, a leading eclectic physician, published detailed accounts of its uses in the mid-19th century. He prescribed it for inflammation of mucous membranes, the linings of the digestive tract, the respiratory system, the mouth and throat. He documented its effectiveness against what he called catarrhal conditions, excessive mucus production, chronic irritation, the sluggish inflammation that accompanied many common illnesses. Other eclectic practitioners expanded the applications. The root was prescribed for digestive weakness, for skin conditions, for minor infections. It appeared in formulas combined with other herbs. It was manufactured into tinctures, tablets, and powders by pharmaceutical companies that served the eclectic market. By the late 19th century, this root was among the best-selling botanical medicines in America. The demand was substantial, the supply was not. And that was the beginning of the problem. The plant cannot be rushed. This is the fact that determined everything that followed. Every economic pressure, every market demand, every attempt to meet the growing appetite for this root collided with a biological reality that could not be negotiated. The plant grows slowly. From seed, it takes 5 to 7 years to produce a root large enough to harvest. 5 to 7 years of shade, of undisturbed soil, of the specific conditions that only mature forests provide. A farmer can plant wheat in autumn and harvest in summer. A grower of this root must wait half a decade before the first return. The plant does not form large colonies quickly. It spreads by rhizome, underground stems that extend gradually, producing new plants at intervals. The expansion is measured in inches per year, not feet. A patch that appears substantial might represent decades of growth. The red berries produce seeds, but germination rates are low, and the seedlings are fragile. Population recovery after disturbance is not a matter of seasons. It is a matter of generations. And the harvest is destructive. The medicinal value is in the root. To obtain the root, the entire plant must be dug. There is no way to harvest and leave the organism intact. Every root collected is a plant removed. Every plant removed is a gap in the forest floor that will take years to fill. If it fills at all, the market did not understand these constraints, or perhaps it understood them and did not care. As demand increased through the 19th century, wild harvesters, often called diggers, entered the Appalachian forests. They knew where the plant grew. They knew the signs, the distinctive two-leaved growth, the red berry clusters, the shaded north-facing slopes. They dug the roots, dried them, and sold them to dealers who supplied pharmaceutical companies. The economics were compelling for the diggers. The root commanded high prices, higher per pound than most agricultural products. For rural Appalachian communities with limited economic options, harvesting this root provided significant income. The work was seasonal, requiring little equipment beyond a digging tool and a drying rack. But the supply was not renewable at the rate it was being consumed. Wild populations began declining. The largest, most accessible patches were harvested first. Diggers moved deeper into the forests, seeking patches that had not yet been found. The average size of roots reaching the market diminished, a signal that mature plants were becoming scarce and younger. Smaller ones were being taken instead. By the early 20th century, the decline was unmistakable. Botanical surveys documented shrinking populations across the plant's range. Entire regions where the root had once been common now yielded nothing. The rich pockets of forest floor that had supported the plant for centuries were empty. The eclectic medical movement, which had driven much of the demand, was itself declining. The Flexner Report of 1910 reshaped American medical education, marginalizing botanical approaches in favor of pharmaceutical models. The eclectic colleges closed. The physicians who had championed plant-based medicine retired and died without successors. The knowledge system that had valued the root was dismantled alongside the institutions that supported it. But the harvesting did not stop. Even as the medical establishment moved away from botanical medicine, consumer demand persisted. Health food stores, herbalists, and supplement companies continued selling the root. The wild populations continued declining. The gap between demand and sustainable supply widened. Cultivation seemed like an obvious solution. It was not. The plant requires conditions that cannot be easily replicated in agricultural settings. It needs shade, not the partial shade of an orchard or a shade cloth, but the deep, consistent shade of a mature forest canopy. It needs rich, undisturbed soil with specific mycorrhizal associations, fungal networks that form partnerships with the plant's roots. It needs years of patience before producing a harvestable product. Some growers attempted woodland cultivation, planting roots or seeds beneath existing forest canopies, and waiting. The method works, but slowly. The investments required, land with suitable forest, years of maintenance without income, protection from deer and disease, discouraged all but the most committed. The result was a plant caught between two forces. The market wanted more than the forests could provide. The forests could not regenerate fast enough to meet the market. Cultivation was possible, but too slow and too expensive to fill the gap. The plant, which had thrived for millennia in the understory of Appalachian forests, was being consumed faster than it could replace itself. By the late 20th century, the situation had become severe enough to attract regulatory attention. The plant was listed under CITES, the Convention on International Trade in Endangered Species, not because it was endangered in the strictest sense, but because the trade volumes raised concerns about sustainability. Export permits were required. Monitoring programs were established. The same root that Cherokee healers had gathered with care and intention was now subject to international wildlife trade regulations. The irony was quiet but precise. A plant that had sustained indigenous medicine for centuries. A plant that had become one of America's best-selling botanical medicines. A plant that contained compounds of genuine pharmacological interest. This plant was now so scarce that international treaties were required to prevent its commercial extinction. The plant did not fail. The market consumed it faster than biology allowed. The chemistry, when modern researchers examined it, explained what traditional practitioners had observed. The root contains berberine, an isoquinoline alkaloid found in several plant families worldwide. Berberine has been studied extensively, though much of that research has been conducted on the compound as isolated from other plants, particularly barberry. The research literature on berberine runs to thousands of studies. The research literature on this specific root is far smaller. This disparity matters. Berberine, as a compound, has demonstrated activity against a range of bacteria and fungi in laboratory settings. The antimicrobial effects are well documented in vitro. In controlled conditions, berberine inhibits the growth of organisms that cause common infections. This is consistent with the traditional use of the root for sore throats, digestive infections, skin irritations, and wound care. But this root is not simply a berberine delivery vehicle. It contains other alkaloids, hydrastine and canadine among them, that are either unique to this plant or present in unusual concentrations. These compounds interact with biological systems in ways that berberine alone does not. The traditional preparations, which used the whole root rather than isolated compounds, may have been accessing synergies that modern reductionist research has not fully characterized. The anti-inflammatory properties have attracted particular attention. Some of the alkaloids in this root appear to affect inflammatory pathways at the cellular level. The mechanisms are not fully mapped, but early research suggests modulation of signaling molecules involved in the inflammatory cascade. This is consistent with the Eclectic physicians' observations about mucous membrane inflammation, the conditions they treated most frequently with this root. The bitter quality of the root is not incidental. Bitter compounds stimulate digestive function. They trigger the release of digestive enzymes and stomach acid. They promote bile production. The traditional use of this root for digestive complaints, the sluggish digestion, the discomfort that follows meals, the sense that the gut is not working efficiently, may be explained in part by this basic physiological response to bitterness. The topical applications also have plausible mechanisms. Berberine and related alkaloids applied to skin create an environment hostile to many common bacteria and fungi. The traditional use for minor wounds, skin irritations, and even eye washes, while modern medical guidance is cautious about such applications, reflects observations about what happened when the root contacted damaged tissue. The tissue improved. The irritation subsided. The infection did not spread. What remains understudied is the root in its entirety. The research on berberine is extensive. The research on this specific root, with its particular combination of alkaloids in the concentrations and ratios that nature produces, is thin. The pharmaceutical research model, which favors isolated compounds with clean mechanisms, has not invested in understanding a complex botanical that cannot be patented, cannot be synthesized efficiently, and cannot be produced at scale. The comparison to turmeric is instructive. Turmeric can be cultivated in tropical fields. It grows quickly, it produces substantial yields, it can be dried, powdered, and shipped worldwide. It fits the supply chain. It fits the supplement industry. It fits the modern market for botanical health products. This root does none of those things. It grows slowly, in shade, in forests, in soil that cannot be manufactured. It resists the systems that transformed turmeric into a global commodity. The biological resilience is notable but constrained. The plant is hardy within its niche. It survives harsh winters. It tolerates the acidic soils of hardwood forests. It persists for decades once established. But it cannot expand beyond its niche. It cannot tolerate sun. It cannot grow in open fields. It is not adaptable in the way that crops must be adaptable to succeed in industrial agriculture. Some growers have developed techniques for woodland cultivation that show promise. Planting rootlets beneath existing forest canopies, maintaining wild simulated conditions, and harvesting selectively after 5 to 7 years of growth, these methods can produce roots of quality comparable to wild harvested material. The approach is sustainable. It is also slow, expensive, and limited in scale. The market has not adjusted its expectations. Consumers continue purchasing supplements derived from this root. Much of the supply remains wild harvested, despite sustainability concerns. Some products sold under the plant's name contain little of the actual root. Adulteration is a documented problem in the supplement industry, and high-value botanicals are frequent targets. The gap between what this root offers and what the system can deliver remains wide. The chemistry is real. The traditional uses are grounded in observable effects. The biological mechanisms are plausible and partially documented. But the plant does not cooperate with the systems that would need to adopt it: the industrial cultivation, the large-scale processing, the global distribution chains. The root remains what it has always been: a forest medicine, bound to a forest, unable to be separated from the ecosystem that produces it. The plant is called Goldenseal. It grows, where it still grows, in the deciduous forests of eastern North America. From Vermont to Georgia, from the Appalachian ridges to the hardwood hollows of the Ohio Valley. It favors the north-facing slopes where moisture gathers and sunlight filters through layers of maple, oak, and beech. The forest floor it requires is soft with decades of fallen leaves, rich with the fungal networks that connect tree roots in patterns science is only beginning to understand. The plant is small. It rises barely a foot above the ground. 2 large, palmately lobed leaves emerge from a single stem. In spring, a small white flower appears, unremarkable and easily missed. By late summer, a cluster of bright red berries forms, the only conspicuous thing about a plant that otherwise disappears into the forest understory. Below the soil, the rhizome is bright yellow. Cut it open, and the color is unmistakable, a deep, almost golden yellow that stains skin, cloth, and everything it touches. The indigenous peoples who used it knew this color. They used it as a dye as well as a medicine. The color is the signature. It is how the plant is recognized, how it is named. For those who wish to find it in the wild, the search requires patience and knowledge. The plant grows in specific habitats, mature forests with closed canopies, rich soil, adequate moisture. It does not grow in disturbed areas, in young forests, in places where the canopy has been opened by logging or storms. Finding it means finding the kind of forest that is itself increasingly rare, old growth or near old growth, undisturbed for generations. Wild harvesting is now regulated in many states. Permits are required. Seasons are restricted. Harvest limits are imposed. The regulations acknowledge what took too long to recognize, that the market consumed this plant faster than nature could replace it, and that continued unregulated harvest would end in extinction. For those who wish to grow it, the requirements are specific, but not impossible. Woodland cultivation begins with acquiring rootlets or seeds from reputable sources. The planting site must be shaded, beneath hardwood trees, on north-facing slopes, in soil rich with organic matter. The rootlets are planted in autumn, several inches deep, and left undisturbed. For 5 to 7 years, the grower waits. The plants establish slowly, spreading their rhizomes through the soil, building the underground network that produces the yellow root. The harvest, when it comes, is modest. The roots are washed, dried carefully, and stored. The yield per acre is small compared to any field crop. The income per pound is high. Wild simulated roots command premium prices, but the volume is limited by biology. Some Appalachian communities have begun developing cooperative growing programs. Families with suitable forest land plant small patches, tend them over years, and harvest selectively. The approach preserves both the plant and the forest. It provides income to rural communities. It maintains the traditional knowledge that connects the people of these mountains to the plants that grow in them. The knowledge was never fully lost. Appalachian herbalists continued using the root even as the eclectic medical tradition faded. Mountain families passed down the understanding of where it grew, how to find it, what it was used for. The chain of knowledge is thinner now than it once was, but it remains unbroken. In Chinese herbal pharmacies, berberine-containing plants are readily available. The compound this root is known for can be obtained from other sources, barberry, Oregon grape, coptis, but these are not the same plant. They do not contain the same combination of alkaloids. The specific medicine that grew beneath Appalachian hardwoods, the particular chemistry shaped by that particular ecosystem, exists only in this root. The plant does not grow quickly. It will not become a commodity. It will not appear in lattes or supplement aisles in quantities that match turmeric. It is a forest medicine, and it will remain a forest medicine. Its future depends not on markets, but on forests, on the preservation of the old growth and mature woodland habitats that the plant requires. The root is still there, beneath the leaf litter, in the shaded hollows where the oldest trees stand. It grows as it has always grown, slowly, quietly, hidden from casual observation. The yellow color remains vivid. The alkaloids remain active. The properties that Cherokee healers recognized centuries ago remain present in the tissue of every living plant. The root does not know it was nearly lost. It does not know it was listed under international trade treaties. It does not know that the medical system that once valued it most has largely ceased to exist. It knows only what it has always known: how to grow in shade, how to spread through soil, how to produce the bright yellow root that stains everything it touches and heals what it was asked to heal. The forests are quieter now than they once were. The old trees are fewer. The undisturbed slopes where the plant thrived are harder to find. But where the forest remains, where the canopy closes overhead and the leaf litter deepens and the soil stays cool and moist through summer, the root is still there. It has survived overharvest. It has survived the collapse of the medical system that championed it. It has survived a century of neglect. It continues, as forest things do, slowly, quietly, without requiring anyone's permission to persist.